Alright, as promised, we're going into inverse today. So before we start anything, before I talk about anything, I just want you to have a look at these two data sets. So this is f of x, this is g of x. Look at their inputs, look at their outputs, and see if you see anything, well, interesting. So, if you're not stupid, and if you have eyes, you will notice that the output of the first function is the input of the second function. And then the output of the second function is also the input to the first function. So essentially, this first function and the second function, its inputs and outputs are reversed of each other. So what does this mean? So this is a whole idea behind the inverse function. So let's look at this. Notice that a relation is a set of ordered pairs. So we have A, B in the coordinates. So I have, let's say, in here we have negative 3, 4, 0, 7, 2, 9. So what is the inverse of that? So with the inverse of that, it's actually 4, negative 3, 7, 0, and 9, 2. So essentially, the y becomes the x, and the x becomes a y. And now, let's see what happens to our domain as we changes it. So originally, our domain is, what is it? It was negative 3. Domain was negative 3, 0, and 2. And our range was 4, 7, and 9. And if you look at it, look, they are exchangeable now. The domain has become the range, and the range has become the domain of the inverse function. So that is the whole idea behind the inverse function. And now let's get into some examples. Interchanging coordinates. So how do we find the inverse of this? Well, essentially we just make the y become the x and the x become the y. So we're going to have negative 8, negative 2, negative 2, 0, 4, 3, 7, 4. And since I'm such a kind-hearted person, I've actually graphed that out for you. So, you will see 4, 7, 7, 4, 3, 4, 4, 3, negative 2, 0, 0, negative 2, 8, and negative 2, negative 2, and negative 8. So you look at this and be like, hey, wait a minute. These are all so synchronized in some sort of way. They're aligned. And now if I love this app actually. So if I drag this image to be something like this, then you will see, hey, look, wait a minute, they are perfect. Whoa, this is perfect. So essentially, we have this line of y over x, y equals to x. That is our basic line that we learned in grade 9, has a slope of 1, no transformation at all. And then we look at that, we're like, oh, wait a minute, that's the axis of symmetry of this function. So everything, if you take the inverse of it, it's going to be flipped across y equals x. And that is how inverse work. Right? It's very interesting. I know, surprisingly, even I found that interesting. And now let's talk about an inverse of a linear function. And here we're going to actually show you how to mathematically find the inverse of something. You know, we learn all about interchangeable coordinates. You know, these coordinates, we learn how to flip the y to become the x and the x become the y, that to find the inverse. So how do we actually find it mathematically for a function? Well, I'm going to do it right here. So right here, our function is y equals 4x plus 3. So before you actually do this, you have to make a let statement. Let y equal to f of x. Stuff like that. So now we have y equals 4x plus 3. We're actually just going to move it. So you're going to do this. X is equal to 4y plus 3. That is literally just the inverse. We just have to move the y over to the x and move the x in the position of the y. And now we isolate for y. So let's go ahead and isolate for y. So x minus 3 equals 4y. Y equals x minus 3 over 4. And there we have it. And now I want to go back to question 1. And let's do that for question number 1 as well, because why not? I just wanted to prove it to you guys. So this is equal to y plus 1. X minus 1 is equal to 2y. Y is equal to x minus 1 over 2. And you can see here, this is how you mathematically find the inverse of a function, of any function, in fact. You just switch the y over to the x point, and then you put the x where the position of the y. Now, I didn't graph this for you, but this was our original graph, 4x plus 3. So something like that. Okay, no. Something like this. It's a very steep line. Now, our inverse, it's actually a more complex than that. So x, this is a pretty well, not so steep line. It's a very not steep at all, because this is actually x over 3 minus 3 over 3, which is 1. So it's actually something like this. And obviously, without a doubt, that is a function. So yes, the inverse of this is a function, but you will see why it asks that stupid question soon. So we're looking at an inverse of a quadratic function. So let's do with the whole thing that we did a while back, well, just 2 seconds ago, and see how to find the inverse of this. So now we put the position of so this is x, and this is y. Now we have to isolate for y. So let's do x plus 1 equals y squared. And now what do? Square root both sides. This cancels out, and now this has a plus minus. So y equals plus minus root plus 1. Now remember what happened, what we did last class. If we have positive, this was just the original function that moved 1 unit to the left, right guys? This was just the function that moved 1 unit to the left, right? So you had this. But now if we had a negative of that, that was in front of the bracket. So if it was in front of the bracket, what was that? That was negative f of x. So what does that mean? It flipped across the x-axis, right? Math. We're mathing here. So we didn't graph the original function. Well, I'm going to graph it now, because why not? So it was negative 1. So I'm going to graph it right here. This was the original function, and this was the inverse. So look at it and be like, oh, wait a minute. That's not an inverse. Well, I mean, it is an inverse, but that's not a function, right? It fails the vertical line test, because for every x value, there's 2 y values. That's not how functions work. That's not how x's work. If x's work like that, then we wouldn't have functions at all. So now we're like, hey, wait a minute. So what exactly happened here? And now I just magically removed half of it. Is this a function? And everybody will look at me and be like, yeah, that is a function, because it passes the vertical line test. And no matter how many lines I put there, there's always going to be one y value for every x value. So wait a minute. How can we exactly make sure that our inverse is a function? We're gonna learn that here. So, but I wanted to talk about that as well. So remember our last domain. Whenever our domain for the x squared minus 1, it looks something like this. So our domain was x equals all real numbers. S is a list of all real numbers, and y has to be greater than negative 1, greater or equal to the negative 1, and then y is a real number. So now what is our domain now? We flip everything except for the fact we have to flip the letters. So now it's y equals all real numbers. So the inverse is y equals all real numbers, and then x has to be greater than or equal to negative 1. X is a great number. X is a real number. So you can't just flip everything and be like, oh look, the domain is now restricting the y. That's not how it works. The x, no, that's not how it works, right? So domain, this is our new domain. This is our range. We just flipped it. So that's pretty much it. Because no matter how you flip it, your range is always going to be the y values, and your domain is always going to be the x values. So I asked you guys a question a couple seconds back. How can we limit the domain? So essentially, our inverse will become a function. You only want half of it. So what can we do to limit? So we only have half here, half of the quadratic function. Well, we could have done some limit to the x and something like that, but we're gonna look at here. Let's restrict the domain of f of x. So let's first find the inverse, obviously. So y equals x squared plus 2. And we're going to have x equals to y squared plus 2. And then we isolate for y. I'm sure you guys can do this in one step as well. Don't worry. So we're looking at it, and this should be pretty much nothing different like the last question. It should still look something like this, right? Oh, sorry, my bad drawing. It shouldn't curl down. It should just go up. So this is something that's supposed to happen, right? So we're looking at it, no, it's not a function. Right away we can tell, hey, look, that's not a function. Loser doesn't even pass the vertical line test. Mm-mm. So remember I gave you guys a little bit of idea. So what happened if I only want one branches of it? How can I do this? So if I only wanted one branches, let's say I wanted the one above it. And then obviously this was our reflection line, which was y equals, okay, I'm going to draw it down here. Erase that. So if this was y equals x, this was our reflection line, right? Everybody remembers? So now our graph is here. So to get this, we needed something like this. So how do I do it so that I only want half of this parabola? So I have to limit the x, limit the domain, obviously. So let's see. If we limit the domain so that now the domain is no longer x equals real numbers, but rather x such that x has to be greater or equal to 0 because this point is still here. And then x is a real number. So we set a limit on the original function. So this is on f of x, by the way, because we can't actually, well, we can't do a domain on it, but that's going to not affect anything. So if we just limit the domain of this, the original function, we would essentially only have this. Now, I didn't go too clear about why you can't limit this inverse, but I think most people would understand. Remember, remember that domain is limit on x, and then range was on y. And x is always going to be your input, and y is always going to be your output. You can't just limit your output. Remember that for our inverse that looked like this, our y was all real numbers. We can't somehow just limit the output so we only have this. That's not possible. Your output is based on your input. So, but in this case, we can't limit the x because if we limit it, the entire thing would be gone. Because we would be like, oh no, x cannot equal to any numbers across this, and you would erase both. So we can only limit the original function so that the inverse of it will somehow become a function. And now, inverse function really is just a mathematical concept. It's rarely used in anything, but hey, math teachers are the greatest at finding things that's useless. So here we have something that's useless. Even though this, you don't really need to use this. I would personally do it the other way, but all right. So the cost of renting a car is a flat rate of $40 plus so let's actually draw the first. Let's write a function first. So let's say cost is equal to 40 plus let's 0.1. Let's do k because why not? Stand for km, right? So that okay, they gave us the. So originally we have f of x, so this was f of x, and now we have our dollars be the total rental cost, our d. So we're basically saying the cost r, which is the total rental cost. So total rental cost, I'm gonna write TRC. TRC at the certain kilometers at dkm is equal to that. So this is what our function really means. I never talked too much about function notation because I assumed you know. So now we have our d. So we just have to write the same thing. 40 plus 0.1d, right? So that was our cost. So now let's find the inverse first. Let's find the inverse of it first. So let's just say this was just r. So we will go ahead and move the r and move the d. So this side will be d of r, and this will be 40 plus 0.1 r. So this is our inverse, right? And you obviously you can do it for, you can change it to x plus y. But remember, we still have to isolate for r. So it would be really easier if we just did this, by the way. Y equals 40 plus 0.1x. And then you will change them. So now it's x equals to 40 plus 0.1y, and then x minus 40, then divided by 0.1, which is basically times 10. So 10x minus 400 is equal to y. So this is our inverse, by the way. You just have to plug it back in. So if y was equal to rd, right? But now since we flipped it, it was d of r is equal to 10 r minus 400. So what does this mean? right? What the hell does this mean? This means nothing. Nothing. We just found the inverse. What does this mean? So this this stupid little function actually tells us the so original function, it tells us with the amount of kilometers that we drove, we will be able to figure out how many cost, how much is it to rent the car. Now we're gonna be using the cost, so we're gonna see if I paid let's say $600, I'm gonna be able to figure out how many kilometers I drove, which is, let's be honest, it's pretty stupid. But man, there's nothing we can do. It's pretty stupid. It's absolutely useless. Because usually you would tell them and be like, "Oh, I drove 80 kilometers. I drove 90 kilometers," and then they will tell you the price. Now we're doing the reverse. Kind of stupid, but okay. So I just told you how we would use it, which is part C. So we will use it to find, basically, to find the 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 distance driven with the total rental cost. So for example, if my total rental cost, it was, let's say, so I'm gonna move this up, by the way. So 10 oh 10 R minus 400. So if my total rental cost was, let's say, 550, so that would give me 50 times, no, 10 will be 500 minus 400 is gonna give us 100. So we can go ahead there, and now we can see 100. This is in kilometers. So if my cost to rent is $50, that means I drove 100 kilometers. So that is how this inverse function works. However, there is certain limits to this. There is certain limits to this. The inverse actually have a domain now. Because remember, our function is 10R minus 400, right? But what if this 10R is less than 400? So let's say if my cost was $30 times 10. That will give us a negative 100 value. So how can I drive a negative 100 kilometers? So now we have to go back to this, and we have to write a domain. Because remember, the flat rate was 40. So we have to write R must be greater than 40. Because there are absolutely no way that they're going to give me a car for less than the flat rate. Right? So that is how we're gonna go ahead and limit it. So make sure to always use your brain and think about, be like, hey, wait a minute, I have a negative kilometers. That doesn't work. Like I'm gonna tell a fun story. I showed up to my physics class a while back, like a long back, and I put up and then I calculated the velocity of a plane. It was negative 5,000. I'm like, what? Is this plane traveling backwards? And obviously you would know it's wrong, and I went back and be like, oh look, it's a science problem. So now let's look at some homework. These are pretty much reflection of inverses. You should have no problem to do this. So this is writing the equation. No problem to do this. This is basically you're going to find the equation of the inverse as well, and then determine if they're right or not. Which looks pretty much wrong, but you're welcome to find that because they don't have any plus minus. Gonna roast that right there. And then inverse of that, determine if the inverse is a function. So I want you guys to carefully, please, if you don't want to do that much homework, that's okay. That's okay. You know what? That's okay. At least do 16. I want you to please do 16 and 17. 16 will help you restrict the original function so your inverse becomes a function. It matters a lot. Please, most people, they screw up on this part, so please practice on that. And that is all I ask for. That is literally all I ask for.